Good morning all of you. So, today I am going to take you through what are the best practices of making a double glazed unit, and especially I am going to talk about the secondary seal, which is the silicone sealant and its role in while making the good quality insulating glass unit. I am Ravi Shankar. I come from a company called Dow Chemical International Private Limited. And I am working as the technical service and development engineer and the leader for the Dow Performance Silicones. I have been in this industry for close to 15 years and supporting various projects, challenging ones as well as the regular ones throughout my career with Dow. So, I will quickly take you through my agenda today. My agenda is going to cover a few essential parts for making a good DGU. We are going to talk about the secondary sealant and durability. So, a country like India or a climate like India what we have, which is tropical, and I am going to talk about what is that chemistry which can work the best for the application need what we have. Not only here, in many other countries as well as the developing nations, the developed nations, what they are talking about the secondary sealant and durability. And not missing on the important seal, there is one more important seal which is key in giving the durability for the DGU is PIB. So, the polyisobutylene, which is also called as the primary seal, is also very critical, and it imparts a lot of it plays an important role in giving the durability for the IG unit. We are going to talk about spacer types. We are going to see what all it can cause, what is the best thing to use, and some of the good manufacturing practices. So, nothing can come, we can have whatever design we want to do on the paper. If we do not have a proper implementation and a standardized process while making the DGU, we will end up with a bad quality of the material. So, the manufacturing process is very critical, including the workmanship, which is one of the key criteria for manufacturing a good quality DGU. We are going to talk about codes, standards, and we are going to have a comparison of standards as well to see that what suits best for us, and also we will cover some of the installation techniques what needs to be considered while designing the DGU, and not the least, there are few points which we will cover is the joint dimensioning. The design of secondary seal is very critical for the long term performance for the DGU, and the new trends which are coming in the market, their effect on DGU also I will slightly go through with my one slide, which is a cold bending technology. So, essentially this is an agenda. To start with, you all know that silicon comes from the earth crust, which is called as a quartz sand. So, quartz sand is the original raw material for manufacturing silicon, and the silicon metal is the one which is first made from that quartz sand, and this is then converted into a ground silicon, and as a distillation or a chemical plant, this is then converted into a polydimethyl siloxane, which is a silicon polymer. So, this silicon polymer becomes the backbone or the essential raw material for manufacturing sealants and many other chemicals which are made from silicon. So, our interest today is to look at the sealant. So, when we really see the sealant has got few ingredients added to that. Essentially the polymer, which is the basic backbone, which is giving all the properties, desired properties, mainly the durability, the strength and the cross linking, and also forming a rubber part. So, the polymer is very essential, but there are some more additives which are critical while making the sealant. They are like you need to add the cross linkers. So, you have few chains of polymer running through, but it's just linear, you need to bridge them to make it compact and a rubber form. So, cross linking happens. So, the cross linkers are important, and this rate of reaction is controlled or it can be enhanced by catalyst. So, you can use a catalyst to enhance this reaction. Some amount of fillers are added to give an inherent strength. So, they give reinforcement and they improve the physical properties of the sealant, and we add adhesion promoters are added to give good bonding of silicon to different substrates. There are some special additives added which gives like a color or an antifungal or some of the other special features in the product, and there is also a small amount of plasticizer added. This is essential for the gunnability. But if you really look at these ingredients, you can have a product made with very good quality by having a good composition. You can also make a product which is very cheap. You add more filler, you add more plasticizer, then naturally the polymer content goes down and the product becomes, or the behavior of the product becomes totally different. That is the reason when we go to the market, you do not see that there is only one product sold. There are number of products being sold at different prices. The reason for this is selection of the type of polymer, as well as the special as the selection of the ingredients. You can make the composition different, which can work for different applications. There is also different chemistries involved while the sealant is made. When I say chemistry, it is in terms of cure. The basic is silicon, but there are different chemistries which will happen during the cure. One is called as acetoxy cure, there is one called oxime cure, and another is called alkoxy cure. So, we generally talk about acid cure and neutral cure systems. So, I am going to take you through some of that in my presentation and see the impact of what can cause what sort of a compatibility issue with the secondary seal of the DGU. So, this is when you make the sealant and you apply it, it comes in the form of a paste. So, this paste when it is applied, it can flow into any shapes, it can fill into narrow depths, and then it can be completely, it will bond and form a rubber. So, the process of curing from the paste form to rubber is called the cure process, and this is then this is the essential curing agent for our most of the sealants used for our application is through moisture. So, it is a moisture cure system. These are called room temperature vulcanizing rubbers. So, the moisture reacts with the sealant and then it cures. So, that is the way it works for the one part. So, there are two big classification of sealant, one is called as one part and second is called as two part. So, the one part is one which is a ready made cartridge, you get it in the market for your Insight or some of the weather seal applications or some of the site applications where it is very easy to handle and apply. The two part is, it comes in a big drum like a 250 kg part A and a 19 kg part B. These two are mixed at a particular ratio and then applied. The difference between these two is actually the cure rate. The two part cures much faster because it does not require a moisture to really get into for cure. There is a catalytic reaction which happens wherein these A and B react, but the byproduct needs to be released. So, all the joints whatever we make using silicon for any of the applications should have at least one side exposed to the air. So, either if it is one part, it becomes a process where the moisture can enter through, cure, and the byproduct is released, or if it is a two part where there is a reaction which happens within itself and the byproduct is released through the exposed side. So, you cannot make a joint which is completely confined into a space and then apply silicon and then pack it completely. The silicon will never cure. So, it will not fully cure to its strength and it will not give you the desired properties. So, this is an important criteria to keep in mind, that we cannot we need to have a joint which is open at least one side which is exposed to the air. So, essentially we will look at why silicone sealant. Okay. So, the silicone sealant is essentially, why are we looking at silicone here, is essentially when you apply silicone for any external application like a double glass or a weather seal or a structural glazing or a panel bonding, expansion joint, fire stop, pavement, all these applications it is subjected to weathering. So, there is an atmospheric condition wherein this is subjected to rain, sunlight, sometimes it could be an acid rain, or there are a lot of humidity involved. So, sometimes it needs a fuel resistance. So, there are many properties where the product has to withstand against weathering. So, the best part is the UV. Essentially on the building what you essentially see is there is a sunlight which is falling on the building and it has got an UV component. So, the UV light will degrade those materials which have energy lower than the UV in the sunlight energy. So, that is very natural. So, there is an amount of energy which is falling on a particular material, and if that material does not have the strength to hold that energy or resist that, it is going to degrade. So, that is what happens with carbon chemistry products. So, the products which are carbon-carbon or carbon-oxygen are organic sealant. So, the organic sealant like polysulfide or a polyurethane, essentially they do not have a very good durability. I will tell you one simple example. In the automotive industry, people use still polyurethane for bonding the windshield. But if you look at the windshield has got a black ceramic paint around the perimeter to protect that sealant not to expose to the atmospheric conditions. So, the UV degrades the PU, so that is the reason they frit it. So, you do not do that in buildings, because what you use is silicon, which cannot be degraded by the UV in the sunlight, because the bond energy of silicon oxygen or a silicon is much higher than the UV in the sunlight energy. So, therefore, if you really look at this picture, what you see here is the left side is silicon and the right side is polyurethane. So, when it was subjected to a simple accelerated UV testing, the PU completely got degraded when the testing was done for hardly 2500 hours. So, this is like 3 or 5 years of life, whereas the silicon did not get degraded at all. So, this essentially proves that the product which has to be used for an application like what we have in construction should have very good long term durability. Okay. So, this is again explaining the structure of the material. You can see that how silicon is the bond angle. If you really see the silicon oxygen or the silicon bi chains, if you see the angle is around 130 degrees. So, this 130 degrees of angle between two bonds gives it excellent flexibility. So, essentially again in construction applications, if you see, we need to have some amount of rotation or a free movement, which has to be you should have in the product to allow some of the thermal movements. Okay. We cannot have a system which is completely rigid, holding the glass to the frame and does not allow any movement to happen. If that is so, then essentially whichever is stronger, that will prevail, the other one will break. So, what is important is you need to have a material which is tough, but also remain flexible and have good modulus to take certain movement. So, that is what it does with the inherent chemical structure of the silicon oxygen silicon. And also these are the methyl groups which are on the backbone like Me, what you see here, this imparts good hydrophobicity. So, it is such an excellent material with a beautiful chemistry, wherein you get a good long term durability and also you get water resistance. So, this acts as a complete air and water tight seal on applications wherever we use it for. So, this slide again talks about the bond energies of different materials and different chemistries. So, the first one is silicon oxygen, and you can see the bond energy is 108 kilocalories. Okay. So, essentially if you look at, so this is much higher than the UV in the sunlight energy, which is around 90. Okay. So, if you look at carbon or carbon oxygen, they are all much lower than the UV in the sunlight energy, and that gets degraded. So, with time. So, that is the reason you do not get much durability with organic sealants. I know when I started my career, some people were initially using organic sealants and there was tremendous failures. I have attended few of them, thinking that these are probably silicon, and when we really did an analysis, we found that the product was oozing out so much oil, did not have the durability, did not have good bonding, and it came out like a gasket. So, and that was a big challenge. So, the climate like ours, we need to be completely thinking about a long term durability, and silicon has proven that, and we have case histories running in India for 25 years now. The first building which was done in Mumbai was done in 1992. Probably there are some more case histories which I am not aware, probably done much before that, but the one which I am aware of is already withstanding 25-26 years without any failures. So, this essentially also proves that the material what is chosen also chosen for the said application should have good durability, and the durability comes from the chemistry, and this chemistry which is called as inorganic, the silicon, is much more durable than the equivalent or other chemistry like carbon. The carbon chemistries are fantastic, they can be used for different applications, but not for the ones what we are talking about in construction. This is one more thing essentially I want to stress upon and show you is the durability of sealant in terms of stress behavior. All our units, if you take a double glass unit, there are two panes of glass which are bonded using silicon, and it has been put on a building facade, it is subjected to load. There is going to be a movement which will happen either with the full unit or sometimes within the unit because of the thickness difference. So, what you tend to see is the durability of the seal along with taking the movement is very critical, and if you see the silicon here, the silicon was subjected to thousands of cycles on a static as well as on the dynamic cure. So, you make the joint and then cure them and then subject it to movements. You see that there were absolutely no fatigue noticed in different cycles what you have run through. But if you really look at polyurethane or polysulfide, you can see that there are failures everywhere when it is subjected to movement. Okay. So, this is essentially what I am trying to talk about is you have to have a product which is also subjected to movement when the actual use. So, you need to have the product which is much more durable and takes the movement. So, silicon is the most sustainable durable chemistry which has proven to be a better in terms of taking the weathering as well as the movement capability. So, these are some of the typical examples of organic seal, what happens with sunlight and stressing. So, when you make a double glazed unit and then you subject it to sunlight and stressing, you tend to have some adhesion failure. This is essentially happened in some of the sites where I visited, and the outer glass has fallen down few cases, and this is silicon. So, it does not get affected. So, you have the unit remain integral. Okay. So, we are just talking about the product properties, and we will come to the challenges what are also we need to do while to get a good DGU. It is not only just the product, it also essentially talk about the design as well as the application. The second thing is water exposure. When you have an organic seal, when you subject it to water, they tend to swell. Okay, they swell. When you swell and you try to move the units out and you try to push the two paints out, then the primary seal, which is not a load bearing member, it will tend to fail. Once the PIB fails, what you get is you essentially get a failure of IG and then you get into a condensation. Whereas silicon seal, they remain exactly the same whether you expose it to water, nothing happens to the product. The third thing what we need to also understand is the wind load and stresses. So, all the glasses which are put on the external facades or any applications are subjected to wind load and stresses. You may have some buildings which are straight facades, something which are inclined, something which has got a different pane thickness. So, everything is subjected to wind as well as the stresses because of the pressure as well as on the dead load. So, there are many loads which are acting on the product. So, if you take an organic seal here again, this will with time it will become hardened, it will become brittle and crack. Okay. So, whereas the silicon with wind load and stresses has been proven, and this is the important thing we need to understand is it allows the movement to happen either in the form of two units moving together this way or that way because there are some internal deflection which might happen. So, essentially the seal has to keep them in tight. Okay. They should not allow the paints to really move so differently, so it imparts any stress on the primary as well as on the secondary. So, that is what is the beauty of silicon. The silicon seals proves again a better product in terms of chemistry than other chemistries. So, what is an ideal sealant requirement? What is that we need for the secondary seal of DGU? So, this is a very essential point to understand. You have to maintain the structural integrity of the IGU. So, that is what is the secondary sealant meant for. It has to hold the paints together and make them act like one and give like a structural integrity. And so, in doing so and also if you talk about the primary seal, keep moisture out of the IGU airspace. Okay. So, the primary seal should not allow the moisture to come in or the gas not to leak through. So, keep insulating glass inside the IGU airspace. You have to keep that gas. So, if you have gas filled DGU, that gas should not leak out. So, when we talk about sealant here, we are talking about both the seals. So, both the seals together have to work in coherence, so that you end up with a good manufactured quality DGU. And environmental stresses, there could be temperatures which could be lower in winter, higher in summer, day and night. So, there are a lot of variations. So, the sealant should not be should not have a property which varies with this. It should have a minimal impact because of the environment and keep that stresses designed to take that stresses, so that the unit becomes more durable. Remain unchanged for the life of the IGU. Generally the IGU has got its own life. So, during that life period the sealant should not give away. And what is also important to understand is when you apply the sealant primary or secondary, they are getting bonded to different materials. It gets bonded to the metal spacer, it gets bonded to the glass coating, it gets bonded to the other accessory materials, okay, like a spacer and then glazing materials. So, sometimes the weather seal comes in contact with that. So, what is essentially we need to understand is this should be compatible. So, the material which are coming in contact with the sealants, they all should be checked for its compatibility prior to use and resist outgassing. Okay, there should not be any outgassing which should happen when you make the DGU, and incorporating desiccant is the standard way of doing a DGU today. But there are other methods of doing it wherein we do not need to fill a specific desiccant into the spacer. The spacer comes with the imbibed desiccants. So, there are spacers available with those technology as well. So, this is one of the project wherein there was a typhoon and there were corner glasses which were replaced, and somebody had replaced it with a double glazed unit made with a organic sealant. So, after the typhoon, only the inner glass and the spacer remained, because inner glass was structurally bonded to the system using silicone sealant. The outer pane, which was the DG which was made with organic sealant, the outer glass has fallen out. So, I have seen this personally in my experience on some of the complaints, and I could really see that how this sealants behave when it is exposed to the climatic conditions like what we have, and also the loads and stresses what it is subjected to, and also to the water. So, what is important also to understand is every product has its own property. Okay. Individually they may be having different values, but what is important for us to have is when it is combined together while making the DGU, the unit or the combined system should have the best durability. Okay. So, if you see here, this is a moisture vapor transmission rate. So, the silicones have higher moisture vapor transmission rates. Okay. So, that means the moisture can pass through, and then that is the way it cures. If you remember my initial discussions on the curing, I said the moisture enters and it cures. So, these are all permeable to moisture to a certain extent, but if you really see at a temperature of 20 degrees and the temperature of room temperatures, if you see also the high temperatures, the difference between the organic and the silicon ratios gets reduced, because organic sealants tend to behave differently with different temperatures in a more larger extent compared to silicon. So, but if you really see what is the best seal which has got the lowest moisture vapor permeability is the polyisobutylene. Okay. So, a system made with the best possible the secondary seal which is silicon and the primary seal PAB gives you the long term durable DGU. So, individually you may have some values of organic sealants which are good in moisture vapor transmission rates, but when it boils down to a combined unit, if you see this slide, so the values we saw that were like in multiples, but when you make a DGU, so this was done in a DGU and subject to a 3 millimeter membrane, and it was subjected to temperatures. You can see here at this temperature the already the polysulfide has beaten silicon and it started absorbing more moisture. So, the individually you may have a product or a chemistry which is good, but when you make it as a DGU, what happens to the long term performance when you subject it to temperature? This is not unusual. If you have an air temperature of 30, 35 or 40 degrees, which is very common in India and multiple locations, the surface temperature of the glass really goes up very high. It could be 20, 25, 30 degrees difference. So, the 65 is not very uncommon, it is very common in India. So, you tend to see that already the organic system has taken over the silicon, because silicon, as I mentioned to you, the variation in properties because of climatic and atmospheric conditions are very minimal. Okay. So, what is the key point? What is that we need to take away from this discussion is secondary sealants hold the panes of glass together. So, they are essential to structurally hold them, and silicone sealants perform this function better than any other sealant. So, we have seen n number of tests, n number of experimental results showing how silicone outperforms other materials. Adhesion loss of the secondary seal will cause degradation of the primary seal and premature fogging. So, any other chemistry which can lead to adhesion loss, if there is an adhesion loss in the secondary seal, that will the load will come onto the primary seal and it will fail, and there will be premature fogging. Primary seal ensures gas and moisture tightness. Okay. The moisture as well as the gas leakage has to be arrested by the primary seal, because that has got the best moisture vapor transmission rate, which is very low. Now, we will come to the function of an IGU edge seal. So, I am going to talk about essentially the secondary seal as well as how it has to be done and what are the tests needs to be done while making the DGU, and and what are the good quality control exercises we need to do for the material as well as for the finished product. So, these are like, if you look at here, this is exterior glass, this is interior glass. The classification is the exterior side is called as 1, the inside is called as 2, and the third, and this is the inside is 4th. Normally in most of the commercial buildings or some of the high end hotel or the institutional or nowadays on the even the residential building, this entire DGU gets structurally glazed, where the structural silicone will be applied here, okay, and then bonded to the aluminum frame. So, here if you look at these two are paints, and this is the metallic spacer which has got a desiccant filled in, and the butyl is applied to the edge of the spacer, bonding the spacer to the glass, and then keep the spacer in place, and the spacer provides rigidity to the DGU in terms of keeping the paints. And the secondary sealant here is the one which provides you the structural integrity of the IGU, okay, under all relevant loads, whatever is the load you have. And the secondary seal bite is always measured from here, okay. This is the bite, and this is essentially minimum is 6 millimeters, okay, and this is the air space. Normally this is 12, and it depending upon the conditions and the requirement, this varies to different air gaps. So, resulting performance challenges for glazing. Okay, what do we do? Well, we use DGU to control heat loss in cold climates to retain the heat. So, which is exactly opposite to what we do it here, and in our country, like which is warm and sunny and tropical, we admit daylight with minimal solar heat gain. So, the selection of the glass, definitely I am sure that the glass manufacturers would have given you enough knowledge about the type of glass to be used for a climate like what we have here. So, I will not go into that details. So, here you need to have a convection and conduction, thermal radiation, solar radiation. So, you have all these factors which happens on a DGU, and choose a coating in such a way that you get the minimal solar heat gain and also the admit the daylight, okay. So, there are other things which are working on dynamically control solar heat gain, glare, and redirect the incident sunlight more effective rather than just making an island effect. So, there are work happening around the point 3 and 4, whereas the 1 and 2 is almost the manufacturers of glass along with the system guys like the sealant manufacturers and then the other fixing manufacturers have almost addressed that 1 and 2 to a large impact, larger effect. So, this is just to give you a brief on how the U value changes with different composition in a DGU. So, the single glass pane will give you the highest U value, it will be more conductive. So, the function of having a DGU is to reduce the thermal conductivity. So, the U value gets reduced, but you have a solar heat gain which has to be also taken care of by using a proper coating on the glass. So, just by doing a double glass, this gets more than half. So, this gets reduced by half. So, you get less conductivity. So, by doing different combinations of triple, low E coating, gas filled, and then argon or a krypton. So, you can do a combinations of that, you can look at when I say combination, you can have a low E coating with an argon or a low E coating with a krypton, and then different types of low E coating, single, double, and then different types of double and triple paints, the U value can be reduced. So, today the U values are achieved to the best, and which are essentially good for the cold climates, and then also sometimes for our own climates, but what is important is U and the solar heat gain both go hand in hand.